Step 2. Find the physics equation that corresponds with those variables. Yes? That corresponds with x and y. Do you remember what step 3 is? Sometimes if we get lucky, we don't have to do step 3.
We have to rearrange to make it a y.
Right, yeah. Sometimes our formula will just already be that, but we might have to rearrange. So rearrange that physics equation so that it's whatever the y variable is equal to everything else. Okay? And step 4? With the manipulated x. Yeah. So. I'm just going to say new x data. So if we have to manipulate the x data like we did yesterday where we squared it, we took that data and plotted the new graph, and then we had a straight line. Hi.
So like when you rearrange it to make it a y equals, it's going to have like something else with the x on the other side, and that's what you do to get your new x plots, is what's on the other side.
That's what you do. Yeah, so if x
hit
hit
your new y.
like to get this new x data?
Isn't it like changing the y data?
No, your y will stay the same. Like the points that you put on the graph for the y will always should stay the same, right? Because when we made those graphs, it was the FC with the V was your first one, and then it was the same FC with the different V. So when you looked at that physics equation and you saw what had changed about the V was squared in your physics equation, you made the data so that the V was squared.
Oh, you have to pick the one that looks like this.
Mm-hmm. Well, pick the physics equation that
looks like that.
Yes, that would have a similar relationship between the x and the y. Okay. All right. And then I don't think that we did the notes for the next part yet, did we? We just did the example. Okay. So let's go to our notes then and finish our notes for that, and then we'll fill in the summary sheet. I just thought this would be a good summary. Like, you might want to keep this kind of at the front of your binder, because you might want to pull it out when we go back and do these types of questions of like, okay, what were those steps again? You know? Okay? So, let's do... Okay. So, we replotted our straight line graph by squaring all of our x values, which is our v. So now it says, identify the meaning of this graph. Okay, well what we're going to do now, in order to identify the meaning of the graph, oh wait, we have to go read those steps, don't we? Let's back up, let's read the steps because that's what we're going to be doing now. Sorry, I got excited. Okay, so these steps will help us to do the next part of that question, okay? So these are the steps for interpreting and analyzing a straight line graph. Interpreting and analyzing that straight line graph is often means find the slope and figure out what's going on there. And that will usually, like if we're trying to solve for an unknown variable, usually we need to figure out slope. You know, not all the time, but often. Or the y-intercept. You know, whichever one, we're usually asked to find that. Okay, so what we're going to do is you try and take your physics equation. So identify what is the manipulated x and what is y. Okay, so that's the first thing. We've probably already done that by now, because if we've straightened it, we've already done that step. But if you didn't straighten it, it's like, you know, like if it was already a straight line to start with, you start here. Okay. And then step 2, identify or create the physics equation that describes this. Okay? So we've already done these 2 steps if you've already straightened it. Okay? rearrange the equation to isolate for y. Okay, already done that. Number 4, identify where the manipulated variable is in the formula. So identify where it is. Now, this is kind of the new part. Any part of the physics formula that is separated by an and or a plus, okay, so by a plus or a minus, and is not multiplied, represents the y. So anything that is plus or minus is the y-intercept, because we know in a y equals mx plus b, the plus b is the y-intercept. So it's like all of the stuff. So if we think about y equals mx plus b, this b could be a negative or a positive, correct? Okay. It's the only thing in the whole formula that is added or ever subtracted, correct? Okay, so if there's anything in your physics formula that has an adding or subtracting, it will always go to the end for the y-intercept. And I will give you an example of what I mean. Okay, so that's really important to remember. Anything added or subtracted, y-intercept. The y-intercept can be made of one variable or several variables. So this could be like plus b ac, right? Like there could be other stuff attached to this b. But if anything is added or subtracted, okay? Like it's like that chunk. Huh? If the physics formula has no adding or subtracting, then the y-intercept is 0. So if there's nothing added or subtracted to a physics formula, your y-intercept is 0. Any variables left in the equation that have not been accounted for as either x or y or x-intercept are grouped together to represent the slope. So any variables left are the slope, okay? So anything else that's not like your x or your y-intercept is your slope. Okay, so I guess when I gave you those summary sheets, I should have gone like steps 1 to 6. Sorry about that. So let's go to our summary sheet and just put this in normal language, or just simpler language. Okay, so we'll have to add 5 and 6, my apologies. So step 1, or let's just, we could be even lazier and say the same steps 1 to 3. 1 to 3 is the exact same, right? From the other procedure. Do you see that? Okay. So same as curve 3. Well, I don't know.
Don't we need 6 steps for that one?
Yeah, we do. We have to put in 5.
So couldn't you just put in one, like step 1?
I know, but now I'm thinking that we should actually put in each step, because when you're doing these questions and you're wondering what to do, then you can just read the steps. Let's just write them in. I'm sorry. I was trying to be lazy, but we should just do it. Okay? So step 1. Find x and y. Find physics equation. Number 3, rearrange equation so y is equal to everything. Identify where x is in formula. Number 5. Anything added or subtracted is y-intercept. And step 6, everything left is slope, or m, and then we'll just go plus b. Because if we've already found y and we've already found x, we have y equals mx plus b. Okay? That's why everything else left can be the m. Okay, so now let's do an example. Yeah? Is this confusing, or are you kind of following what I'm laying down?
They do need an example for like the everything left is.
Yes.
Because I can't picture it.
Okay. Okay, so we had ended with D, right? Okay, so in part D of our question, we're going to do the next steps, okay? So what we ended with was that we had already, oops, what's going on? We had already identified that x was the variable v squared, right? X was v squared, yes? Okay. And we said y was fc. Maybe I'll put an equal sign so that it doesn't look like a negative, okay? So that's identifying those. We had identified our formula as fc equals mv squared over r. Okay, great. Now the next step was to identify where x is in, well, I guess the next step was to write it so that it's y is equal to everything, but we got lucky and it already is. The next step was to identify where the x is in the formula. Well, there it is right here, right? And I'm using a color to show you specifically how it's different from everything else, okay? So even if you want to just highlight that little part or something. So I would actually rewrite this to help me, okay? And you'll see why when the formulas get a little bit more complex that this can be helpful. So I'm going to rewrite it as fc is equal to m over r times by v squared. Okay? They still mean the same thing, correct? But what I'm thinking is that I kind of want to, when I identify where x is, I kind of want to isolate for it. Because I want to see what's left over. So then the next step was identify anything that is added or subtracted. Are there any variables that are added or subtracted in this formula? No, indeed there's not. So if you wanted to, you don't have to, you can put plus 0 at the end and just know that your y-intercept is 0. This is totally not necessary though, but just for learning purposes. Then the last step said, any variables left in the equation that have not been accounted for as either x, y, y-intercept are grouped together to form the slope. So I think, okay, this has been accounted for, this has been accounted for, all that is left is this. So those variables, what they do is they represent slope. Okay? So this is slope, or we could say that's m. Okay? So in here, this is y equals m. This is my x plus b. Okay? Y equals mx plus b. See that? So to answer the question for D, we would say that slope is equal to m divided by r. That would be the answer for this question. Okay? But we needed to put our physics formula into yx plus b. So that's kind of what you want to think to yourself. So this is what you want to think. You want to think, put physics formula into your y equals mx plus b formula. Because you have to do that in order to identify slope. Okay. Now, the reason why we do that is because then often we're asked another question. And this is the type of question that if you were asked something with a graph and all this stuff on a diploma, this would be the point that you would be asked to do, this E question. And you would have to know to do all those other steps. Okay? So this is the application point. It says use your graph to determine the mass of the object if the radius of the circle is 1.15 meters. Okay, so whenever it says use your graph, that's hint, big time hint, blinking lights, to say use slope or y-intercept. You need to use either one of those, that data that you gather from your graph in order to solve the problem. Okay? So when it says use your graph, that's what it's talking about. Okay? So in this case, I'm going to teach you two ways to do this. This example, we're going to do it by hand. The next example, we'll do it by calculator. Okay? So take out your graph that you made yesterday, the straight line one. Take out the straight line one. Now, what you will do is you're going to find slope with that graph, okay? So, did you draw a line of best fit with it? It's pretty much connect the dots is like your line of best fit, right? Yes? Yeah. Everything connects quite linearly. I don't know if that's a word. And so, to find your slope, what do you use? What's the first thing when you find slope? You need what? 2 points. You need 2 points on the graph. Usually have them quite far apart, like you don't want them super close, a good distance apart. So I would choose one like, about a little bit less than a quarter way up the graph and, a little bit ways down the graph, okay? And the 2 points that you choose for slope usually should not be the actual data points. They should be other points on the line. So pick whichever ones you want. You choose. So you decide, pick 2 data points on your graph. Then you should use those 2 points. So you write out, you can either write it right on your graph or you could do it in this space, whichever one you want. Write out like your x1, y1, okay, as one of your points, and then your x2, y2. What's your formula for slope? Rise over run. So y2 minus y1 over x2 minus x1. So solve for your slope using the 2 data points that you use. And I'll show you the one that I have.